So this video is on Factorial ANOVA, where we're using more variables than just a one-way ANOVA. So with Factorial, it's also called two-way ANOVA. We are using two different factors and seeing if they differ significantly on something else. And the dependent variable, again, is continuous. So here we're looking at test scores and if they differ by type of curriculum, so traditional versus a culturally relevant program, and ethnicity, specifically African American and Caucasian. So in this case, we could do two t-tests because we have two groups in each. If we were looking at three curriculums and we were looking at more than one ethnicity, more than two ethnicities, then we could be doing two one-way ANOVAs, but really that's not the best choice. If we can do everything in one test, we're minimizing our type 1 error chances. So if we again have two independent variables, which we call factors, that are nominal or ordinal, two or more groups, and we have a dependent variable that is some sort of a scale or a test, a continuous variable. So a research question is trying to compare levels of our factors on the dependent variable. And that would be factorial analysis of variance, Factorial ANOVA. Again, it's also called two-way ANOVA. So in this example, we're computing three F-tests. We're doing three different F-tests. And you kind of pick the one that works the best, and I'll tell you how to do that in a minute. So for our three F-tests, we're doing a one-way ANOVA on just curriculum, we're doing a one-way ANOVA on just ethnicity, and then we're also going to do the factorial ANOVA that looks at the interaction of curriculum and ethnicity. So we're going to get three main effects. A main effect for ethnicity, a main effect for curriculum, and then a main effect for the interaction of curriculum and ethnicity. When we get all of these, we're going to check the interaction first. If the interaction is significant, we interpret that and nothing else. If the interaction is not significant, then we're going to go and look at the main effects for each of the two factors. So going back, if we have an interaction, we're going to report this one only, and we're going to ignore these two because they're taken care of right here. If this one is not significant, then we're going to check the main effect for ethnicity and for curriculum and report significance individually. So our assumptions are the exact same as ANOVA, but we kind of add this other one of balanced design. And this has to do with equal cell sizes and unequal cell sizes. So each one of these is a cell. So a balanced design does not mean that every cell is equal or fairly equal with our sample size. That's not what we're looking for, but every option is represented. That means it's balanced. And I would recommend at least 30 in each group, but we can do really unequal groups here and still be balanced. A not balanced design would be here because I don't have any males that took a hybrid class. So that's a big problem in Factorial ANOVA. When we report about two-way ANOVAs, we're talking about two different variables that have different levels within each factor. For example, if we were looking at sex, we would have two levels, male and female. In the previous example, they were looking at curriculum types, and they had traditional and culturally relevant, so that would be two levels. So when we report a two-way ANOVA, we talk about it like this. A 2x3 factorial ANOVA was conducted, and then we keep going. Instead of saying a one-way ANOVA was conducted, this is the setup. So the two IVs, it tells me two factors right here because I have two of them. I could say 2x3x4, that would be three independent variables. The 2 indicates that the first factor has two levels. The 3 is that the second factor has three levels. I could say 3x2, it doesn't matter, it's just whatever way that you are talking about the variables, that should be 1 and that should be 2. So we've seen this table before when we ran one-way ANOVA, when we were looking specifically for the eta. This table gives us a lot more information than we need. So here's everything crossed off that we don't need, that's doing other things that we're not interested in yet. And we're going to focus on these three F tests. There's our F values, there's our significance. This is looking at how letter grade, GPA, so what type of student are you on stats test. This is the one-way ANOVA that we did with one-way. This is our studied by stats test. You can see that is also significant. So these are two one-way ANOVAs. Here's the interaction. So we see the star. This is grade letter groups by our studied groups. And we scan all the way over and we see that this interaction is not significant. So instead we report these two individually instead of looking at the interaction. So when we write these tables, this would be a 2x2, 2x3 design. So I have two factors here, two levels within my student level factor, undergrads or grads. This would be my course type factor, which has 3 levels, online, traditional, and hybrid. These are sample sizes within each group. Now this looks kind of like a chi-square. The difference is that we are including a mean and variance, mean and standard deviation for the undergrads that are online. So this is one distribution. This is another distribution of mean and standard deviation for graduates that are online. Undergrads traditional, graduates traditional classes. So we here have 6 different distributions, and we are looking at, are there differences in these distributions? The main effect is going to see, is there differences in the distribution between these 3? The other one-way ANOVA is going to check the difference between these 2 distributions, and then the factorial ANOVA, the interaction, is looking at all 6 distributions, and are they different? So we have a lot of variance that we're trying to explain here. And it's all based on the dependent variable. So how much of the dependent variable is the variance explained by this factor, like graduate level, so undergrad or graduate? How much of the dependent variable is being explained by this factor, which would be what type of class you signed up for? And then the interaction is, where is this overlap? Here it's very, very small. And this is the interaction that is explained by both of my factors. So let's look at how we do this.